Okay, Unit 9 is on trigonometry, and we're going to start with target 1. I'm going to split this video into two videos so we can look at the two different types of special triangles from trigonometry. We have two different special triangles. One of them is a 45 degree, 45 degree, 90 triangle, and the second one is a 30, 60, 90 triangle. So this first video is going to talk about the first one, and then I'll do a second video over the second one. So what we know about triangles is that we have similar figures or similar triangles, or triangles that are the same size or same shape but different sizes. So for example, I'm using a tool right now to draw a bunch of triangles that are all different sizes, but they all have the same thing in common. They all have an isosceles nature to them. So they're all right triangles with the sides the same. And so we did an activity in class that showed that if you take an isosceles right triangle and you work with some numbers like 2 and 2, then when you do the Pythagorean theorem, the result of doing a squared plus b squared equals c squared, in this case would be 4 plus 4, because 2 squared plus 2 squared is equal to c squared. So 8 is equal to c squared, and c is equal to square root of 8. Well, another way to write square root of 8 is to say 2 square root 2. So this triangle has sides 2, 2, 2 root 2. We did an activity in class where we saw other triangles. 3, 3, this was a 3 root 2. 6, 6, and a 6 root 2. So there's always this relationship in a 45, 45, 90 triangle where the two side lengths are identical because it's isosceles, and the hypotenuse is square root of 2 times that length. So we're going to use the fact that the hypotenuse is square root of 2 times that length to do our problems. Another way we say this is that we have a ratio. The ratio for a 45, 45, 90 triangle is 1, 1, square root 2. And so in the yellow circle there, you see x, x, x root 2. Another way to do that is 1, 1, 1 root 2. Here's some problems or examples on how to use that. Finding the hypotenuse. So we have a side length. In the first problem, A, we have a side length of 12. Because this triangle is isosceles, I know that both of the legs are equal to 12. And before, we would have done Pythagorean theorem to come up with the hypotenuse length, which I just wrote as a c. But now, because of this ratio that we know is true for every single 45, 45, 90 triangle, we don't have to use the Pythagorean theorem. Just to back up for a second, we know that these angles are 45 degrees because you have 180 degrees inside a triangle. And this is isosceles, so the base angles are congruent. And so 90 plus 90 is 180. 90 divided by 2 is 45, so they're each 45 degrees. So back to this, instead of using the Pythagorean theorem, to go from the leg to the hypotenuse, I can multiply by square root 2. So this becomes 12 square root 2, and that's it. I don't have to do the Pythagorean theorem to find the answer. For b, I can do the same thing. I'm going to take my side length, which is 10 root 2, and I'm going to multiply by square root 2. So this is 10 square root 2 times square root 2. You will have to work with square roots as far as multiplying and dividing throughout this unit. So 10 square root 2 times square root 2. One way to think about that is that this is now 10 times square root 4, because we know 2 times 2 is 4. But square root of 4 is the same thing as just a normal 2. So this is, instead of 10 times square root of 4, it's 10 times 2. And 10 times 2 is 20. So this triangle is 10 root 2 for one side, 10 root 2 for the other side, and 20 for the other one. We take the side length, 10 root 2, multiply it by another square root 2. That's my ratio, 1, 1, square root 2. So you multiply the short side by the ratio, square root 2, and that gives me my result. Just want to point out that in triangle A, they told me it was a 45-degree angle, and in triangle B, they did not tell me it's 45. But they show that there's the side lengths are the same, so you know it's isosceles, and it has to be 45. A couple more examples is, what if I have the hypotenuse and I want to go backwards to find the leg? Well, in order to find the hypotenuse, we multiplied, so what we're going to do is divide by square root 2. So x is going to equal 15 square root of 2 divided by square root of 2. We really want you to do this without a calculator. The answer is 15, because right here I have square root of 2 divided by square root of 2. Well, 2 divided by 2 is 1. So I really have 15 times 1. Anytime you take a number and divide it by itself, you get a 1. So 15 times 1 is 15. And so this goes with my pattern of 15 for a side, 15 for a side, and a hypotenuse of square root of 2. For number 6, or for letter B, sorry, we have the hypotenuse. So to find the side length, we divide by square root of 2. And so that just looks like this as a fraction, 6 over root 2. And that's really kind of the answer. But I say kind of because one of the standard things we do in math is that we don't allow there to be a square root on the bottom of a fraction. So this is not considered simplified. So we need to keep going. We need to do something else with my 6 over square root 2. And this will be the last thing I show for this target. So here's how we deal with this number divided by a square root. We want to rationalize the denominator. So a bunch of math words there to say that we want to take this irrational number on the bottom of the fraction and turn it into an integer, so something without a square root. The way that we do that is multiplying by itself, because if you square a square root, you are inversing the square root, and so it goes away. Square root of 2 times square root of 2 is going to be square root of 4, which is just the number 2. Now, I can't just multiply the bottom of a fraction by something because that changes the fraction. But if I multiply the top and bottom of the fraction by the same number, I get an equivalent fraction. So technically, my fraction on top, or my number on top, is 6 square root 2. The number on bottom is 2. I can then simplify and say that 6 divided by 2 is the number 3. And so what I have left over is 3 square root 2. Please watch that part of the video again if you need to. That's going to be a skill that is unusual for us, but it's going to show up, and so we can practice working on that. I'm going to go over the 30, 60, 90 triangle in a second video.